Hello, Pamela. You're muted.
Hello.
Nope, and now I can't hear you. Oh, there we go. All right. Yay! Welcome back.
Thank
Before we
you.
get on to the
Um,
show, where were you?
I spent 2 weeks in Australia, traveling kind of all over the place, doing two or three things a day, and it was all an amazing whirlwind. And at some point, I'm going to get around to blogging it and posting pictures. But first, I have to catch up on all of the email that was still left over from when you and I recorded when I was in Lisbon, and still left over from Dragon Con, and I'm going to be home until February, so hopefully I'll be able to get everything under control.
Now, I don't know if you're seeing it, but I'm seeing a big delay going on somehow. I'm not sure whether it's on my end, on your end.
Yeah,
Yeah, so we're just going to have to work
it's on
through
my
this.
end. I know it's on my end, and I'm tempted to reboot because my computer started madly whirling as soon as we went into the holding pattern. Do we want to do that?
If you think it'll improve the quality of your computer, then by all means, go ahead and reboot.
Okay,
Okay,
I
cool.
shall return.
Perfect. Well, and then it was just Fraser. Um, so, and unfortunately, I got to apologize to everybody here. The Q&A app doesn't seem to be working again. So, for some reason, I turned on the Q&A app and it didn't function. So, I'm not even able to even answer questions and interact with the audience. So, anyway, for those of you who've just joined us, this is going to be a live episode of Astronomy Cast. Are you rebooting, Pamela?
I'm working on it. It's slowly closing everything down, very
Okay, I
slowly.
see. Right, and the last thing will be you winking out as the computer shuts down. There she goes. Okay, cool. Yeah, so this is going to be a live episode of Astronomy Cast. We're going to take about half an hour to record this live episode, and then when we're finished that, we'll stick around and answer your questions. Now, the problem is that the Q&A app is not functioning, so we're going to have to come up with a different way that we can handle your questions. So I propose that we'll do two things. One, we'll use the event page over on Google+, and the way you can find that is if you go to the Astronomy Cast page on Google Plus, you should be able to find the event page. And I would read out the URL, but it's just a lot of gibberish. 1150071069615. Anyway, you see how this goes. Yeah, so we'll go ahead and use the event page, and I can see it right now. And so go ahead and put your questions there, and we'll answer those questions there. Cool. Okay. So, and just to sort of let you know, give you sort of a sneak peek of what we've got. So this week we're doing Comet Siding Spring, which is quite appropriate because Pamela was actually in Australia at Siding Spring for the unveiling of a new telescope there, and I'm sure she's going to explain that when she gets back. And then what else have we got? We've got next week we're going to be talking about 3D printing in space. And then we're going to go into a series, a multi-part series, which I know a lot of people like. And we're going to be talking about women in astronomy. And so we're going to be featuring a bunch of sort of modern astronomers who, most of them are still alive, we're at sort of the end of their career, and a lot of the big sort of the discoveries that they've made and contributed to astronomy, because a lot of folks in astronomy, a lot of the working scientists are women. As you've seen from like the breakdown of all of the shows that we do, when you look at all of the Cosmic Quest stuff, we have Nicole, we have Pamela, and Emily Lakdawala, and a lot of women working in this field. So folks like Maria Zuber, Carolyn Porco, Margaret Geller, Jocelyn Bell, Sandy Faber, Vera Rubin. So yeah, it's going to be great. Let's see what else is going on right now. I'm going to use this time to do some shameless self-promotion. So we just released the latest episode of our Guide to Space video over on YouTube, which was Why Can't We See the Big Bang? And so this is this question that if we're able to look back, as we look out into space, we look backwards in time, we get all the way back to 13.7 billion years ago, we should be able to see the actual Big Bang happen. And yet we can't. So why not? And last week we did what does a black hole look like? And the terrible irony of this is that I sort of gave an answer of what a black hole would actually look like. And then literally a couple of days ago, the folks from Interstellar, this movie, the new movie by Christopher Nolan, they did a simulation with Kip Thorne about what an actual black hole would look like. And apparently, Kip Thorne is a very famous astrophysicist who's done all of these simulations of black holes. And the simulation they came up with and the way they created it for the movie, for Interstellar, is so good. And they learned so many new things about it that they're actually going to be writing research papers about this, about the simulation that they created for the movie Interstellar, which that just gives me the shivers when you think about the quality of the simulation. So I'm going to try and find a picture of it because it's so cool. But the article about this was over on Wired. I shared it on Twitter, but you can find it on over there. So let's see if people are able to find the event page. There we go. So Hugo Burnham says, my computer takes 20 minutes to reboot. So hopefully we'll see you sooner. Nancy Graziano asks, has there any progress been made towards getting Patreon, Kickstarter, et cetera, approval? So I can sort of half answer this, which is that, as you may know, I've got a Patreon campaign for Universe Today. So you can go to patreon.com/universe today, and we've got the sort of the benefits for all of the people who support Universe Today. All the ads are removed from the website. I'll follow you on Twitter. You get sneak previews of all the shows that we do, and of course, just that you're able to help us out. But the question that's been asked a lot of times is, why don't we have a Patreon campaign for Astronomy Cast? And way back in the day, when we actually started up the Patreon campaign for Universe Today, we wanted to do one for both Universe Today and Astronomy Cast. The problem is that Astronomy Cast is run out of University of Southern Illinois, Edwardsville, and so and it's sort of part of a 501(c). It's a nonprofit organization, and so it's a lot more complicated for us to get the approvals within that organization to be able to actually run a Patreon campaign through there. But that's been mostly worked out, and I think we were waiting for Pamela to get back from this trip to be able to concentrate on it. So I think we're going to try and get that rolling in the next couple of weeks. So stay tuned on what the Astronomy Cast Patreon campaign is going to look like. But if you are looking to support, you can always still donate over at CosmoQuest. Donate to Astrosphere. And that can help make sure that money can go to Astronomy Cast and CosmoQuest and all the projects that we're working on, as well as go to Cosmo Academy, and you can sign up for courses, which also helps out what we're doing. Let's see if there's any more questions. If you do, you can just go to the event page on Astronomy Cast, and we will show. Let's see, I will answer any questions. You can also use Twitter. So my Twitter is fkane, which I put right there. Is that you back?
Yes.
Is it working any better?
We'll know in a moment. I think so.
Yeah. Maybe it's my fault after all.
We'll see.
Yeah, so you can just go ahead and tweet at either me or Pamela while we're doing the show, and you can, and then we'll get the question. So she's Star Strider with a Y. I'm F Kane, and go ahead and ask us a question if you want, and I will watch. Okay. Are you watching wheels spinning?
I'm waiting for GarageBand to open.
Yeah. Is this
There
where I
we
make the plug for
go.
Audacity? No.
No,
No, I don't. I don't dare.
I am happy with my system.
Sure you are. So why don't you regale
Okay.
us with some stories while you're, if can you multitask while you're getting your system set up?
Yeah, and I think I have everything set up now. I saw a kangaroo with a joey in its pouch.
Aw,
So
like just
so
in the
like
wild?
yeah, it was hopping around up at Siding Spring Observatory. We were getting ready to have a barbecue after the Starfest open house weekend, and I'd been trying to get photos of these big red birds that didn't want to be photographed. And so I had my camera out, and everyone's like, "Come over here." And I'd seen some wallabies, but I hadn't seen a kangaroo at that point, and it was like full-fledged, big old gray kangaroo, and she kind of had like one ear droopy and one ear up, kind of like, huh? And little Joey in the pouch that was like, huh? And so they looked kind of like stoned kangaroos, but they were happy. And kangaroos look really stupid when they try and move slowly because they can only hop. It's the only way that they can move. And so they'll do like this really lazy kind of hop. And yeah, but
That was
they're
awesome.
awesome when they're going full tilt.
So why don't we save the your actual visit to Siding Spring? Because I'd like to sort of give some of the history of Siding Spring and some of the stuff that you did up there. We'll save that for the show
Yeah,
itself because you were there, which the timing is perfect.
I I was indeed.
Yeah. So
And
let me know
my
when you're ready.
internet really sucks.
Yeah, I think it's your
I'm
internet.
ready. I'm just should I shut off my video? I know that makes for a crappy experience, but I'm not sure what else to do.
Well, are we getting any kind of delay in the back and forth? I think it's okay now. Like, yeah, you're
I
definitely
think
look
okay,
like
yeah.
yeah, you definitely are looking like a stop motion animation, but I think, as long as you're able to hear me and you're able to answer, I think it should be fine.
Okay. I'm going to put something over this window because how bad my video is actually distracting. But okay, I'm
Yeah.
good. Everything is now set up
Okay.
and hard drive has stopped whirring.
Okay.
And
I'm going to press record
okay,
then.
I have pressed record.
Testing, testing. Good. Okay, ready here. And let me just say, I hate the internet. Okay.
Uh, okay, I hate the internet as well.
Yeah.
I
Also
suspect we have
computers.
different reasons.
Yeah. Also technology. Okay, here we go.
Yes.
Uh, Astronomy Cast, episode 354, Comet Siding Spring versus Mars. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. My name is Fraser Kane. I'm the publisher of Universe Today, and with me is Dr. Pamela Gay, a professor at Southern Illinois University, Edwardsville, and the director of CosmoQuest. Hey, Pamela, how you doing?
I am doing well. I am, in fact, doing far better than my internet connection is. So if any of you hear any weird uh, context to our voices, it's because we have lag today.
Right, and so if I ask a question and then there is this long, well, you know what, Preston will fix it. So if there's a big long pause after I ask a question, and then Preston will fix it, and the audio listeners will have no idea that there's this terrible herky-jerky video while we were trying to record this episode of Astronomy Cast. But this is what we get. This is karma coming back when
Yes.
you travel around the world. You get to have awesome adventures in Australia. You get to see kangaroos, and you come back, and the internet isn't going to play nice.
Well, it's not just the internet isn't going to play nice, it's that my home computer died a bitter and brutal death upon hearing that my husband's getting a new computer. Like, literally, he said, "Hey, I'm getting a new computer." And at that moment, as I typed in my password to get rid of my screensaver, it died. and tomorrow the hard drive gets replaced at the Genius Bar.
See,
So I'm
I was sure that
in
this
my
was
office.
a good chance for you to just completely throw out that computer and get a new one. Hard drive's dead. I need one of these brand new Retina iMacs, the 5K display. But I guess you weren't able to make that kind of agreement with the pocketbook.
Well, NASA kind of like canceled the program that I've been relying on for the majority of my funding for 6 years. And so knowing that the possibility of getting new funding from NASA on that particular grant call is zero has made me realize all of everything needs to go into making sure that the rest of my staff at CosmoQuest, you don't necessarily have husbands getting brand new computers, are okay.
Right. Austerity
Donate,
measures are in
please.
place.
Yeah.
All right, so let's get cracking. So we were witness to a once-in-a-million-year event, so we have been told, a close approach of Comet Siding Spring to the planet Mars. And fortunately, humanity had a fleet of spacecraft orbiting the red planet. Now that's a once-in-a-million event, a million-year event. Ready to capture this monumental event in real time. What did we see? What will we learn? So before we go into this, you were in Australia you actually, part of what you were doing, and one of the big reasons why you were there, was that you were helping with iTelescope's
dedication of a new 27-inch telescope. Right. So I just spent 2 weeks. Unfortunately, I got home before the flyby of Comet Siding Spring. I was down in Australia for 2 weeks and talk, but a lot of the activities that I did were around the Siding Spring Observatory Open House Weekend, which is called Starfest. And iTelescope took advantage of Starfest to dedicate a new 27-inch telescope that is named after 3 women astronomers, Jocelyn Bell Burnell, Annie Jump Cannon, and Dorrit Hofflet. And they had myself and Amanda Bauer, who is a senior fellow down in Australia, had the 2 of us do the dedication of the new telescope.
That's fantastic. And so, I mean, they must have been pretty psyched about the Siding Spring close encounter with Mars.
It was really the thing that everyone was talking about. First of all, it was a discovery made by a really amazing astronomer who's also just a nice guy. So it was discovered by Robert McNaught using the Uppsala Southern Schmidt telescope, which is a nice half-meter telescope with an amazingly large and beautiful field of view. And because of their tradition, it's not Comet McNaught. We've had those.
We've already had those.
He's, as I said, an amazing astronomer. But since he was using one of the national facilities, it was named after the observatory itself and got the Siding Spring Observatory designation. And it was discovered back in January of 2013. And it's one of those telescopes that it does great work. It's one of those scientists who does great work and is a great guy. And then it was a comet that a lot of people on the mountain had gotten to get time in on following. Peter Lake, who is one of the engineers and educators at iTelescope, actually took a number of the images that went into calculating the orbit of this particular comet. And getting at the orbit of this comet was one of those things that had a lot of us on the edge of our chairs for quite some time.
So it's important to distinguish between this comet and, for example, Comet 67 Churiguri, which is this is the term that Emily Lakdawalla has given it, and so we're all just going to go with it. If it's good enough for Emily Lakdawalla from the Planetary Society, it's good for us. But yeah, just to distinguish between Siding Spring and 67P, they are 2 different kinds of comets. So what kind of comet is Siding Spring?
It is a comet that is probably on its first round through the solar system that is coming in from the Oort cloud. So when it was discovered last January, well, 2 Januaries ago, back in 2013, it was out at a distance that, had it been ideally placed in stellarium, would have been nice and neat between Jupiter and Saturn. It was out a little bit beyond 7 astronomical units away from the sun when it was discovered, and it's on its way in from the Oort cloud, and it will take it order of a million years before it comes back into the inner solar system. So this isn't a once in a lifetime, it's a once in this geological epoch kind of comet. And it not only came in, but then decided it was going to give Mars an unprecedented view that actually allowed some of the spacecraft at Mars to get the highest resolution images we've ever had of an Oort cloud comet.
And I think that's the really important distinguishing feature here, which is that Rosetta, and there's been a mission to Halley's Comet, and there's been the Stardust mission. Yeah, so we've had close encounters with comets before, but the problem with these Oort cloud comets is they come out of nowhere, they buzz past the sun, and then they head back out into the outer reaches of the solar system, and so you just can't task a spacecraft to catch up with them or do a flyby in time. But nature just did the next best thing.
Right, and while it was a small comet, it was probably somewhere between 500 and 700 meters in diameter. It got so close to Mars that even the Mars rovers down on the surface of the planet were doing imagery of it. It got within about 86,000 miles of the surface, 130,000-ish kilometers, and that, while being further away than some of the moons, in the grand scheme of things, if we were comparing that distance to the distance of an Earth's geosynchronous satellite, it would have been closer.
And we happen to have the most powerful telescope operating around another world, which is the Mars Reconnaissance Orbiter, has the HiRISE instrument, which is a really powerful telescope used for observing Mars, but it was able to observe Siding Spring as well.
Right. And so this is where these really high-res images are coming in. They took exposures of varying lengths so that they could get a good look at the coma, the fuzzy cloud of gas and dust that's reflecting sunlight around the nucleus. They took shorter exposures so that they were able to try and get a good view of that nucleus. And so these are the highest resolution images that we've gotten so far. And the other neat thing was we just stuck a couple of new spacecraft into orbit around Mars, and one of those new spacecraft was the MAVEN mission, which is designed specifically to study atmospheres and has things like particle detectors on board. And this comet just happens to have left a few particles in the atmosphere of Mars.
Yeah, absolutely. Well, I mean, when the comet was first discovered, there was concern that it was actually going to hit Mars.
Yes, this is where the sitting on the edge of the seat part comes in. It was a couple of months while the error in the orbital determination was sufficient that while the orbit looked like it wouldn't coincide with the surface of Mars, the error circle still overlapped with the surface of Mars. And the concern was, if you have this brand spanking new shiny atmospheric detecting spacecraft orbiting the planet just as you, hit the planet with something that we at the time thought was maybe a couple of kilometers across, you really have to worry about what all's going to get thrown up into space. You're looking at a crater that's tens of kilometers across for that 1 to 2 kilometer impactor. It turned out it was much smaller, so that wouldn't have been an issue, but it still would have done damage. And as it is, it put enough extra debris and, more importantly, enough extra heat into the upper atmosphere of Mars that it significantly increased the drag on the spacecraft. And so they're going to have to put more effort into maintaining orbits, and it may have actually shortened the useful lifetime of these spacecraft. We're still
Right,
figuring that out.
and so if it had actually hit Mars, from what I was reading, it would have pretty much shut down human exploration of Mars for decades. That it would have kicked up so much dust into the atmosphere, it would have made the environment, completely obscure. Like, none of the orbiting spacecraft could see the ground. The Mars rover's on the ground. Nothing else could land. Like, we would be blocked from Mars for decades.
And that was probably more dire than reality, simply because you're looking at this twofold problem of Mars doesn't have sufficient gravity to pull things out of the atmosphere very quickly. But at the same time, it doesn't have an extremely thick atmosphere. So you end up with situations where you'll end up with storms on the surface of Mars that obscure most of the surface when they get going.
Yeah, we've seen this.
But then winter comes and you freeze the atmosphere out of the atmosphere. And so these massive hemispheric changes in where the poles are as you freeze the southern atmosphere out and grow the southern pole, melt that, and then freeze it back down at the North Pole, it becomes hard to figure out just how long would that dust have been in the atmosphere. But yes, what you're saying was the most dire of predictions, and there was talk of even potentially putting the MAVEN spacecraft into a different kind of orbit to get to Mars, just in case they needed to hold it back if that impact was going to occur, and figure out new orbits and things like that. Storing a spacecraft on Earth and delaying launch is a great way to get your mission canceled, to ruin your spacecraft. Earth is the least safe place to store a spaceship.
Right.
But once it was in orbit, there was at least literally room to maneuver.
Right. And so, but this maneuvering was still important because, if you read a bunch of the articles that were coming out just before the pass, they were talking about how the spacecraft were taking cover.
Yes. I just have this mental image of like all the spacecraft slowly poking their solar arrays around the limb of the planet as they
cowering behind Mars. Yeah.
Yes. So they did take care to put the spacecraft in orbits that would allow them to be maximally behind Mars during that closest approach. Now, MAVEN has admittedly only a several-hour orbit. The same is true of the fabulously functional Indian spacecraft. But they did what they could to get them behind during that critical time as the spacecraft passed by, not the spacecraft, as the comet passed by at a relative 56 kilometers per second.
And so, let's talk a bit about what the various spacecraft would be capable of seeing. From the ground, who was, we had Curiosity, we had Opportunity, they were able to see it from the ground. Right. So what would they see?
Well, it's awesome because those images are online. So we can go in and we can look at Mars Reconnaissance Orbiter's high-rise camera images. We can look at Mars Exploration Rover has this great image of it in the constellation of SETI. I haven't so far, but this doesn't mean they're not out there. I haven't so far found images from Curiosity, but MAVEN is already making atmospheric measurements and looking at, yes, this is a spacecraft that dumped temperature into the atmosphere. And the way you do that is the particles, as they go through the atmosphere and burn up, their kinetic energy, their motion energy, and their chemical energy ends up getting shed as heat energy into the atmosphere. And so there may have been as much as 40 Kelvin added to the upper atmosphere.
Now, here on Earth, right, like when we have meteor showers, that's because we're going through the tail of a comet. And
Right.
so Mars has gone through the tail of the comet. Will the
Right.
rovers get some meteor showers?
So they did see a meteor shower, or they would have had they had sufficient resolution to make out a meteor shower. But the neat thing about the way comet geometry works is that tail is always pointed away from the sun. The tail does not stream out behind the comet because of the motion of the comet. It's actually pushed outwards from the sun by the solar wind. And the comet's tail itself didn't really have a close encounter with Mars. It was more the particles from the coma. And one of the images that really got my attention is someone combined an Earth-based image and an image of Mars that showed the orbital size of Phobos and Deimos. And um, at closest approach, there was 135,000 kilometers between the center of the comet and the center of Mars. And Mars is only about 6,700 kilometers across, whereas the visible coma of the comet was 20,000 kilometers across.
So it was bigger visually
Yes,
than Mars.
yes.
Yeah.
So that cloud of sunlight reflecting dust and debris was more than 3 times the diameter of Mars.
Yeah.
And
So, and then of course, you got the Hubble took some pictures. As you said, MAVEN is probably one of the most interesting instruments there because MAVEN isn't a telescope. It doesn't even have a camera. But it is designed to look at atmosphere, to look at atmospheric particles and dust, and what a perfect target for it to watch.
and it's probably going to take quite some time to figure out everything that happened because there is going to be a long-term decay in the effects to the atmosphere, and they're there to see them. So they're
Yeah.
going to be able to see how long does it take Mars' atmosphere to return to the state that it had prior to the comet. And this is one of the really neat things with the timing of MAVEN is it did get there just in time to get a solid baseline of what does Mars' atmosphere normally look like. And now it's going to have for however many days, weeks, months, or even years that it takes for the atmosphere to de-puff, and it's probably going to be order of weeks to months. It's going to be there to see all of those changes and to actually measure changes in the chemical properties of the atmosphere that in part reflect just different molecules being around due to changes in temperature and also what the comet left behind.
Yeah, I mean, one of the interesting things about this is that MAVEN wouldn't have been ready to take observations. They were going to go through their whole shakedown period. They would have done all of their, tested each instrument and done all of their baselines, as you said. But because there was this once in a million year opportunity to get these shots, they had to get MAVEN to return a bunch of data about Mars immediately when it arrived to be able to get this baseline. And so now they're going through the proper instrumentation, to bring everything online now and getting all of their calibration over the next few months. So it was a strange. They took advantage of an amazing opportunity, but to push the spacecraft into science a lot earlier than they would normally have done.
Right, and it is one of these kind of amazing times when all in all, this wasn't a particularly distinguished comet. It wasn't even the brightest comet in the sky that night. There are actually a number of different comets currently visible. There's 2012 K1 Pan-STARRS at 7.5 magnitude. There's 2013 V5 Oikoumenden. It's a Japanese named one that I'm sure I just destroyed the name of, that's at magnitude 7.7. Comet Siding Springs is only at magnitude 10, so it's significantly fainter. But it almost hit a planet. And there were a
Yeah.
whole lot of us in camp go boom. I was really hoping for an impact so that we could really
Oh,
see the physics.
you're a
Um,
monster.
I am. I truly am.
Yeah.
But we haven't figured out how to solve the radiation problems for human beings going to Mars yet. So I'm good with making it a little difficult to go there for a little while
Yes.
because physics. I mean,
Yeah.
think of everything we could have learned with these rovers on the surface, with all of these spacecraft in orbit, and we would have got to see what is the damage caused by a small comet. And that gives us insight into what we need to be looking for. We're pretty good and pretty thorough at finding the multi-kilometer stuff out there. We know that we're missing a lot of the hundreds of meter stuff out there.
Um, yeah, yeah, absolutely. It was a funny sort of watching. Like I was quite tuned in to as the event was happening, and I was tuned in. There was a bunch of hangouts, the folks at the European Space Agency, and a bunch of other. I know SLU and iTelescope did live coverage of the comet, and I think everybody was expecting or hoping for this kind of, the telescopes, the various space missions to come online and start streaming their views, and it was a bit of a letdown as
Tiny.
as all of that data, nothing came out. There was some great shots from amateur astronomers here on Earth, and then it took a couple of days for the actual pictures to start percolating out and becoming available. And people, I could see this sort of sentiment out there on the internet. People were like, well, that's it? That's all? We didn't get to see much. But yet I'm sure the scientists they're out of their heads excited with this opportunity to see this first time close-up images of a Oort cloud comet, a long-period comet. And
What I was really enjoying was watching the people who are the scientists on the various teams tweeting things along the lines of, "Oh my God, can't tell you," and the sheer excitement of what they were seeing that they're not allowed to share. And I'm so sorry, Preston, I just totally blew my mic levels on that. Um, the people were so excited to share. And the problem is you can't just release a raw image because the public doesn't know how to deal with a lot of the weird features that you get with CCDs and occasionally decide things like lens flare is a UFO. So
yeah, but no, there's good folks like Emily Lakdawala, who at the Planetary Society, who is watching the raw feeds coming out of the spacecraft, is able to clean these things up and do a good job. And actually, we do it all the time too
yes.
at Universe Today. Jason Major and Bob King. We've got a bunch of people now on our team who are watching these raw feeds, and as soon as a picture came out, we were literally refresh. And in fact, Bob King was one of the first people to see it in Opportunity's view. So, no, I think they can release this stuff in the raw. I think they did. I mean, they released this stuff out pretty quick.
They did for a lot of the spacecraft, but I don't think they did it for all of the spacecraft. We actually have a question coming in from Twitter. Rashan Bakari is asking, could Curiosity rover actually use the ChemCam on the comet? It could try, but the problem is it just wasn't bright enough to do spectroscopy with an instrument like that. A lot of times what you really need is a whole lot of bright light, and I think ChemCam may actually have them heating things up in an oven. I have to admit that's not.
And they have a laser.
Right.
There's a laser that it zaps things with. But so what's going to happen next then? I mean, the comet has passed Mars. It's passed out of the field of view of all of these robots. It's going to go around the sun, and then it's going to leave us.
It's going to spend the next year slowly getting fainter and fainter and fainter until we no longer care because it's not bright enough for the telescopes most of us have access to. But then it's going to happily return its way to the Oort cloud unless it decides to collide with something along the way, and statistically that's not going to happen.
And then we'll see it in a million years.
Not us, but
us in our third robot bodies, absolutely.
It's fascinating to imagine, though, a million years from now, ignoring climate change, destroying society. But if you imagine that we figure out how to continue surviving on the surface of our planet, will they still have knowledge of our early observations today that they can use to try and understand it in that extraordinarily distant tomorrow?
I
And
can
how
just
much will they
imagine.
make fun of
Yeah.
us the way we use Galileo's sketches occasionally to go back and try and figure things out. Um, yeah, you've got to wonder.
You can just
I've got to wonder.
imagine some kind of future, yeah, press release coming out where they update the orbit of the comet Siding Spring by a zero point 0.1 degree, thanks to the second observation having it return. It's 3 weeks off schedule. Okay, so and I guess sort of where this goes, and one of the holy grails of planetary astronomy is to send a mission to a long period comet. We've talked about long period comets in the past. What would it take to actually get something that on purpose got close to a comet and maybe
What
even orbited it and went along for the ride?
Well, you don't really orbit comets. You sort of zigzag along beside them because you just don't have enough gravity. And you pseudo-orbit them, basically. But in order to do that pseudo-orbiting, zigzagging, orbiting the sun alongside that icy body, you'd really need to have a spacecraft not too different from Rosetta out there in a parking orbit with a whole lot of maneuvering fuel on board, ready when you get that year and a half notice as it comes in from Jupiter, to be sent to intercept it as it gets close to the sun. It's kind of expensive to have spacecraft in parking orbits, but there's always the hope, and it's not a futile hope, that we'll have a spacecraft like Epoxy that got used for one purpose, and when it's done and it's still fully functional, gets repurposed to go and visit something that happens to have a serendipitous orbit.
Yeah, and I think you're exactly right. It would be something that's maybe orbiting out in the Jupiter range, which can do a slingshot around Jupiter when a comet trajectory is known and the math works. And this thing would be all fuel, and it would be able to increase its speed tremendously to be able to get into a proper orbit, because these things are
Right.
moving fast and they're completely unpredictable. We don't know where they're coming from. So that would be amazing. Okay, cool. Well, thanks a lot, Pamela,
It
and
was my
welcome back.
pleasure. Thank you. Thank you.
All right, let's shut this down and we will save it.
Saving.
My Dropbox is full, so if you could, at some point empty out a bunch of stuff, that would be super.
Oh. You just totally did that in the
I
Office
know.
Space
I
voice.
know. You get those TPS reports. That would be super.
Yeah, I can do that. I'll do that.
I'm going to need you to come in on the weekend.
Yeah, I do that anyway, so deal.
All right. All right. Awesome. Okay. I have saved. All right, let's get to the questions. So I'm going to take some from Twitter first. So from Rashan Bakari, also, can a spacecraft be tracked while put on a comet into the Kuiper belt or the Oort cloud? Hitch a ride on a comet. So I guess that's kind of exactly the question that I just asked. Could you get a lander onto a comet and have it hitch a ride?
Well, Philae's gonna not go anywhere once they manage to land it on the head of the giant flying duck of ice. Assuming it lands safely. We'll know in a few weeks. So we're already going to be doing this, but the thing is, the surface of a comet is a kind of violent place, and eventually there's probably going to be a jet that opens up underneath that poor little spacecraft and sends it back into space. Or, as it moves away from the sun, that coma is going to freeze off, and you have the potential that you're going to then encrust your spacecraft. And even if that doesn't happen, we don't really have the radiothermal generators to do something like that right now. We just can't waste them on that high risk of emission.
Yeah, and so once you get out of the life-giving heat from the sun, you're having to run on one of these thermal generators, and there's only so long you can do that before these things just run out of fuel.
Yeah,
So,
it's a really frustrating.
yeah, more nukes. Why
Yeah.
can't we have more nuclear plutonium used for this purpose? All right, well, let's move
Yeah.
on. So Noel Ruppenthal asks, how is the orbit of Comet Siding Spring affected by the gravity? What happened to
Um,
it?
its orbit was bent. It was seriously bent, and I'm trying to look real fast. I don't remember which direction relative to the sun it was going, and that allows you to see if it was getting sped up or slowed down. One of those two things happened. It would have been gravitationally sped up. So its orbit was bent, sending it closer to the sun and closer to Earth's orbit than it would have gone otherwise, and it was accelerated by the process.
Noel also asks, my friend wants to know, how fast would a chicken orbit around the Earth?
It depends on its altitude.
Mm-hmm. Yeah. Yeah, so anyone who's played
It
the
has
Kerbal Space
nothing to do with the
Program
mass of the chicken.
knows, yeah, knows that how this all works. And really, it's just the higher your altitude, the faster you're moving, but actually the slower you're moving compared to the ground.
Right.
So,
So if the chicken was at the same height above the Earth as the International Space Station, it would be going 4.8 miles a second.
yeah, about 27,000 kilometers an hour. But if it was at the height of the geosynchronous, the geosynchronous satellites, a geosynchronous chicken, as it were, it would be moving 0 compared to the ground.
Yes,
So, and there
compared
would always be there would be a chicken in every sky at all times. So. Dave Hart says, "Sorry guys, but the lag is making me want to yell at my device. We apologize for
Yeah.
Pamela's horrible internet."
Yes, this is why we do edit things before they go out on the podcast. You guys are simply getting to watch the sausage being made, and it's not always pretty.
Yeah, I don't think there's any fixing this though.
Yeah, when I'm on campus, it's hell. And I'm sorry, but my hard drive failed gloriously at home. So yeah.
Hugo Burnham says, "Pamela Gay" by Ray Harryhausen. So that's the time lapse. Harryhausen is the guy who did a whole bunch of those sort of classic monster movies back in the 60s and 70s with stop motion animation. Well, that's it. I think those are all the questions that we've got. So,
Okay.
but if you want to hear really tough questions, if you haven't already, we have put our live astronomy cast at DragonCon episode into the feed, where I got the chance to ask the toughest questions I could possibly imagine to a team of willing victims, and it was a wonderful time. Yeah, what was great was that the topic had been originally suggested by one of the people on the panel, and he had thought it was going to be something like, how do we deal with the tough questions in astronomy? I guess how to deal with the people who think that there's UFOs visiting us, and how do we deal with where we're dealing with uncertainty and all that kind of stuff. And I just took it as, what are the tough questions in space and astronomy?
I will give you credit for not asking how magnetic fields or dust affect anything. That's the normal tough question in astronomy.
Yeah.
And I'm also going to put a plea out. We're trying to figure out how to make up all of our NASA funding that pays for our infrastructure. We still have the funding for all of our citizen science projects, but we don't have the funding to pay for our day-to-day salaries starting a few months into 2015.
Now, that's
And
not day-to-day salaries for us, because I don't take a salary. You don't take a salary from Astronomy Cast, but
no, but this is my day-to-day salary for CosmoQuest.
yes,
And it's Corey's salary and Joe's
yeah,
salary and our whole team here at SIUE and some of our folks at other universities.
yeah.
And so we are looking for corporate sponsorship at this point. And I am writing NSF grants like a mad fiend.
Right,
But
you're very good at it. So
yeah, but unfortunately, everyone else is doing the same thing. I just got a grant back, and they said they had over 500 applicants for 20 grants, and they were sorry, but I was not one of the 20 out of 500 selected. And
yikes. Yeah.
so
Yeah.
we
and I mentioned, people asked earlier what was going on with our Patreon campaign, and I mentioned that there was some sort of legal issues in dealing with it originally.
We have those worked out, and we're
Yeah.
getting ready to launch that. I have all of the approvals. I need to finish the NSF grant I'm writing first.
Yeah.
But I expect to be working on that next week.
Well, and we've been running our Patreon campaign for Universe Today now we have 400 people. So
Yeah.
I've learned a million lessons, so I'm glad to apply those lessons to what we do with Astronomy Cast. So,
yeah.
Cool. Okay, well, let's wrap things up. So thanks, everyone, for joining us. Thanks, as always, Pamela, for bringing your brain. It's not too upside down. And we will be back again normally on Monday with our 3D printing episode, and then we will be around all the way from now through February, we hope.
Yes.
Well, I might be going away in January, but anyway, we'll figure it out.
Thanksgiving week.
We'll figure it out.
Raise question, yes, but probably not. It's U.S. Thanksgiving.
Yeah, I don't even understand what that means.
It means a university holiday.
Okay. Thanksgiving in November just makes no sense to me. Have it in October, the way it properly should be done. Oh, there was one question, actually, that I thought I would get to before we go. This comes from Alsuran Baltazan, which is that how do you manage all of this travel with sort of home life and trying to sort of, stick around the house, and you've got a horse and all those responsibilities, and especially, do you have any recommendations for people who are in a relationship where both people are academics and have to do a lot of travel? So
no children. If we had children, it wouldn't be tractable.
Yeah.
My husband has a really solid 9-to-5 job, and is extremely passionate about blues music and guitars, and so all of his spare time that doesn't go into randomness like cooking dinner goes into his refurbishing old guitars, building new sound pedals, working on our home studio. And so he can be completely forgiving of me doing my late nights writing grants because he's blasting his amps, and I like the music he plays, so that works for both of us.
Well, and also he has a lot of flexibility. I mean, he works with the computer,
right?
And so he has a lot of flexibility on where he is, and so he's tagged along for, he came on the Astronomy Cast cruise that we did. He's gone
about
to
once a year he'll travel with me.
Yeah.
In general, simply because he doesn't fit in airplane seats due to height.
He's a big man.
Yeah, he makes Fraser look short. But the other thing is, I have to admit, I don't stop. And this is something that I know does drive my husband a little bit crazy. I don't know how to sit still. I'm not ADHD. I'm easily bored and hyper-focus. So
join the club. I think Yeah, we're
It's
cut
it's
from the
how
same cloth on that front.
yeah, so I will get up and I will check Facebook, and uh, my Facebook feed is filled with scientists, so I'm catching up on the latest science news at the same time, and I'll do that while I'm drinking my coffee in the morning, go over my email. I'll have podcasts on while I'm doing the type of work that doesn't use my whole brain, like reviewing Trello cards.
Hmm.
Um, and then I will make the purposeful choice of I'm going to get up at 7 a.m. on Saturday and Sunday to go out to the barn and muck stalls. And I do board my horse, but I help out at the facility where I board my horse.
Hmm.
Um, and it's everything I do is done purposefully and is scheduled. And I also, luckily, am someone who um, only needs 7 hours of sleep a night, and I can get by on 5 or 6 for a while, and then I'll just sleep for a whole day.
Yeah,
Um,
and I mean, I think for me, because I have kids, I just turn a lot of stuff down.
yeah,
So I don't travel as much as Pamela does, and I could absolutely have the opportunity to travel that much, and I just say I can't, I won't, and I really try to pick and choose. And a lot of the things that I'll do, I'll take my kids to Dragon Con, or I'll take my
yeah,
kids on that cruise, or they're pretty flexible with that kind of stuff. And so
they're awesome.
yeah, and it's tough. I mean, I think if both of you are going to be research scientists and both of you are going to try, the competition's going to be tough, and you're going to try to get into whatever jobs you can, and that could very well have you in different places. That's going to be pretty tough. I
You
don't
you
know an
have
easy
to
solution to that.
you have to be extremely individual.
Yeah.
This is where my husband and I met in our 30s. We'd both had our own lives, and we are very much married, but at the same time, neither of us is going to basically melt away in heartbroken devastation if they're left alone for 2 weeks.
Yes. Or
And
3 months or whatever. Yeah. Yeah.
yeah,
Yeah. Absolutely.
so if he goes on a business trip, it usually means that I'm going to pull the power tools out and work on something at home that would otherwise create a lot of noise and mess. If I'm gone, he's going to have the amps up all the way. And when I've been home too much, he starts, when are you going to the barn? When are you going to the barn? Because then he can be super loud while
Yeah.
I'm gone.
Yeah. And have all his buddies over and playing guitars and yeah.
Yeah, and that
Yeah.
happens. And
Yeah, totally. So I mean, there's not an easy solution. It depends on the personality of who you guys are and how you interact and how independent you are.
mhm.
Um, it's easier when you're older, I think, to be independent in that way, to sort of, because a lot of the big life decisions have already been made, and you're kind of comfortable in your skin, and you
Yeah.
like spending time together, but you also like spending time apart and being yourself. So it's tougher when you're young and you're just trying to get all of these things done simultaneously, but you can't count on that one thing to happen, right? Like boom, you both got it offered a job in the same city at the same place. That's a long shot.
Yeah.
So you got to be kind of
And
prepared for the downside. So
and I'm watching this with the two grad students I have right now. One of them commutes into campus 45 minutes because their significant other is also a grad student, and they managed to find universities that are an hour and a half apart, so they live at the midpoint between the universities. My other grad student, their significant other lives on a coast, and so they have to fly to see their significant other. And it's a hard life, but getting into grad school is a hard thing to do. Noisy
yeah,
Astronomer went through that with her significant other while he was finishing up his master's degree. And you make sacrifices, you figure out how to celebrate when you get together. And it's gotten to the point where the dogs actually get more pissed off than the husbands. I come back and his dog growls at me because she has to give up her side of the bed because it's now my side of the bed, but she's going to growl at me. And my dog won't let me go to the bathroom alone for a few days after I get home.
yeah, yeah.
So
That's funny. All right. Well, now we got to wrap this up. Now
Okay.
we've gone over time, so that's to make up the 20 minutes of me or 10 minutes of me filling
Uh,
time at the beginning. So,
okay.
hey, again, thanks, Pamela, for doing the show. Thanks to everybody for watching. Follow me, F Kane. Follow her, Star Strider
At
with a
Star
Y.
Strider.
Y Star Strider.
I was dumb in
And
my 20s.
and we'll see you all. We're gonna do the weekly space hangout tomorrow, and then we'll see you all next week. Thanks, everyone. I have to find that window. I couldn't even watch.
It was. I buried it too. It
Yeah.
was
Okay. There we
horrifying.
go.
I'm so sorry.
Yeah.
I
All right. Here we go.